Okay, so to summarize what we talked about, if we start with position, and that is our original function, or f, the rate of change of position is velocity. The rate of change of f is the derivative of f, or f prime. The rate of change of velocity is acceleration. The rate of change of the first derivative is the second derivative. Okay, so looking at this graph, this represents, the graph below represents, this should say velocity of a particle when it's moving along the x-axis. So I have velocity and time. So this is v of t, or the first derivative. This wants to know at what interval is particle acceleration positive. The particle's acceleration would be positive, or the first derivative, or the second derivative would be positive when the first derivative is increasing. So I want to know when velocity is increasing, is what I'm looking for. So acceleration is positive on, and we're going to say the intervals here in the second. So this, since velocity and I'm increasing b to d and d to e. So if I'm looking at the interval where the derivative of v would be positive, it'd be b to d and then d to e. So I'm looking for where the derivative or slope of v would be positive or where it would be increasing. So similar idea here, where is a particle acceleration negative? So acceleration is negative on, we'll find it in a second, since v of t is decreasing on that interval. I'm going to change our marker color really fast from A to B. The slope of v is negative, or the derivative would be negative. C asks, where is the particle's acceleration 0? So I'm looking at the particle's acceleration is 0 when the derivative would be 0 or undefined. So I'm going to clear what's on here. So my derivative would be undefined at b. That'd be undefined. And here, v prime would be 0 on that interval as well. So we're going to say I'm looking for would be 0, and we'll say the points since the derivative of v of t equals 0 or undefined. So this is at point B, and from E to F. Okay, what do we mean when we say velocity is negative? What does it tell us about the particle's position? So if the velocity is positive, that tells us the position is moving to the right, and if it's negative, it means it's moving to the left. So it tells us about the particle's position. The sign of velocity tells us direction. So when the velocity is negative, the particle is moving left. We will not have up and down or vertical particle motion. We'll just be moving left or right. So the particle is moving left when velocity is negative. The particle is moving right when velocity is positive. So go ahead and try to write statements for these. So I would say the particle is moving left. I'm looking for where it's negative, so that's B, this part, or B to C. Sorry, not B, A to C. Since the velocity is less than 0 on that interval. And then I'm going to look for where velocity is positive. The particle is moving right. When my velocity is greater than 0 or positive, and that's all of this. So it's moving right, 0 to A, and C to F. Since my velocity is positive on that interval. So we can think about the relationship between the first derivative, second derivative, and the original, like the relationship between, we'll use that to think about the relationship between position, velocity, and acceleration. And then when velocity is positive, it's moving right, and when velocity is negative, the particle is moving left.